For example, 1, 2, 3. So for example, let us take like this real-time example on let us take. In this class total 80 students are there. Okay, total 80 students are there. Now these 80 students, I have kept an exam, and out of 50 marks, and for 50 marks they have taken the exam, and the students has got 40, 41, 42, 38, 45, 32, 26, 49, something they have got like this, so on up to 50 every student has got. Now how I'm going to analyze this data? For example, all the 50 students marks are there. So if, for example, Naresh IT team, they are asking me, sir, how the students' performance is there? Miss, should I explain all the students one by one, the marks of each and every student? No, right? I can't explain each and every student. Just I'm going to say what is the average value. That average value indicates the entire data. The entire data you are going to say with certain values. Those values we used to call as measures. Okay. So here we are going to measure the data by using different measures are there. One is called as measures of center tendency. Measures of central tendency. First one is measures of central tendency. Second one is called as measures of spread. How the data has been spread. Measures of spread or measures of with respect to distribution. Okay, you can say in a different way. How the entire data has been distributed. Okay, and whereas measures of central tendency gives the value with respect to one value, specific values. So these both of them are going to measure by taking some values we are going to measure, right? Now here, the first one. Oh, sorry, shit. Sorry guys, without sharing the screen, I have explained. Okay, now it is clear. Now the screen is clear. Okay. So here the measures, what are the measures are there? The measures we are going to do in one is measures of central tendency. Measure of central tendency. One is measure of central tendency, and the second one is measures of dispersion or spread, everything. Measures of dispersion or spread, measures of spread. So how we are going to measure the central tendency and measures of spread, we are going to see one by one. Okay. The first one, we are going to start with respect to the measures of central tendency. The measures of central tendency is given by mode, median, and mean. These three values gives you the measures of central tendency. Sir, what is this measures of central tendency? Central means center value. It is going to focus on the center value, right? So center value, that is median, mode, and mean. Yeah, Ravi, I'm repeating from the starting only. That is measures of central tendency and measures of spread. Before to that, just I have revised the whatever we have discussed in the previous class. Today's class is, this is the first one. Okay. So here we are having the measures of central tendency. These three comes under measures of central tendency. And here the range, standard deviation, and along with that variance. There is one more called as variance. These three comes under measures of spread. How the data has been spread. It is going to explain the how the data has been spread. Okay. So let us see one by one. First, this is called as measures of central tendency, and these are called as measures of spread. It is going to explain me how the entire data has been distributed. From the starting to ending, how the data has been distributed. This is the explaining the spread of the data. This is explaining me how the values has been laid at the center. So the first one is, here I'm having with respect to 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 students are there, and the 9 students heights are there. So this I'm going to have the mode. What is meant by mode means most frequently repeated value. most frequent value. So in this case, which is the most repeated value is 154. So 154 is the most frequent value. So mode is nothing but most repeated value. Sir, for example, 154 was repeated 3 times. Okay, well and good. Let us assume 139. There is one more 139 and 139. 3 times 139 also repeated. This one and this one. Both of them are 139 and 139. 3 times this one, 3 times this one. So now which one is the mode? Means both of them are mode. This is called as bimodal. Bimodal means where you are having 2 modes. When you are having 2 modes, then it is called as bimodal. Sir, if for example, I am having a data like this. 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 5, 5, 6, 6, 7, 8, 9, 10. So these are the numbers. Now in this case, what is the mode? Means 1 is repeated 3 times, 2 also repeated 3 times, and 3 also repeated 3 times. Now in this case, it is a multimodal. Both 1 and 2 and 3, everything are called as modes. 1, 2 and 3. Everything is considered as a mode. Okay. If you have one mode, means if you have only one mode, unimode, then it is called as unimodal. Unimode. Unimodal means only the entire data is going to have one mode. One mode is there in the entire data. Entire data consists of only one mode, is called as unimodal. Unimodal data. That data is called as unimodal data. If the entire data is having 2 modes, if there are 2 modes are available in the data, then it is called as bimodal data. If the data is having 3 modes, then it is called as, more than 2, anything, any number more than 2. It is called as multimodal data. If the data is not having any mode, means 1, 2, 3, 4, only 4 values are there, that too, none of them has been repeated. Then in this case, there is no mode. There is no mode. If repeating is there only, it is called as mode. If none of them has been repeated neither one time, more than one time, then it is having no mode. There is no mode. In this case, I am having 154 for 3 times. So only 154 is the answer. So it is a unimodal data, which was repeated more number of times. That is called as mode. Right? The next one is called as median. Median is called as center position, not the center value. What is this? Okay, median is called as, median is center position value. Whatever the value is there in the center position, that value is called as, center position value is called as median. Whatever it is there in the center position, it is called as median, irrespective of value. Well, we are focusing only on the position. This is most important word. You are focusing on the position. So in order to get the position, first we have to get the ordered array. So ordered. So whatever this particular data means, whatever the values are there, first you have to convert this one to an order, either ascending order or descending order, as per your choice. So I am going to convert this one to an order of ascending order, like this. Now in this ascending order, after converting, what is there in the center position? Total how many values are there? 9. So this one remove, this one remove, this one. So center position is this one. In the center position, whatever the value is there, you are not focusing on the value, you are focusing on the position. In that center position, whatever the value is there, that value is called as median. In this case, the median is 154. If you are having odd numbers, the formula is n plus 1 by 2 is the formula. The formula is n plus 1 divided by 2. N is total number of data points. Total number of data points means total number of data. How many values are there here? 9 values are there. 9 plus 1 by 2. That is 10 by 2. Fifth position is the median value. Your position, median position is given by the formula called as n plus 1 by 2. which is the center position. Okay. So number of data values plus 1 divided by 2. This gives the median position. Sir, okay, here odd numbers is there. You are saying center position very easily. If you are having even number of points, 10 points are there. Now 10 plus 1 divided by 2. 10 plus 1 divided by 2. Then it is going to be the 11, right? Now for 11, now how we are going to do? 10 plus 1 is 11. 11 by 2 is nothing but 5.5. 5.5 is nothing but average of 6 and 5. 5 plus 6 by 5 only is called, 5 by 2 is called as 5.5 only, right? So in this case, you are going to take the average of center two values. Average of center two values, which is equal to 154 plus 155 divided by 2, which is 154.5. Right? Is that clear, guys? So if it is an odd number, means directly the center value. If it is an even number of data points are there, means average of center two values. Right? And sir, average, whatever the average is there, average, that is nothing, sorry, average I have not explained, right? Just let us compute the average also. Now what is the average? Average is called as mean. Mean is nothing but adding of sum of the data points divided by total number of data points. Sum of all the data values divided by total number of data values is called as mean value. Sum of all data values divided by total number of data values. Right? Now, here, the mean you can calculate for the population data. For the population data also, you can calculate the mean. For the sample data also, you can calculate the mean. Okay? Population size is given by caps lock N. Sample size is given by small n, right? Now, the population mean. So, if you are having the entire data, let us take 10, 20, 30, 40, 50. This is the population. Assume this is the population. Total 5 values are there. These are the population. Sample is, I am choosing any two numbers, 20 and 40. I am going to choose like this. Now, for the sample, you are going to apply the mean. That is nothing but all the data points you are going to add. Sum of the data points is given by sigma. Divided by number of data points is given by hash. Symbol is. Hash indicates the number of data points. Okay. This is called as mean. Mean is equal to sigma by hash. In this case, population, that is 10 plus 20 plus 30 plus 40 plus 50, which is divided by 5. 150 divided by 5, which is 30. And this population mean is given by mu. Symbol as mu. Okay. Whereas for sample, again, you are going to calculate 20 plus 40 divided by 2, which is 60 by 2, which is 30. This is given by X bar. Sample mean is given by X bar. And population mean is given by mu. All the population parameters will be indicated. All the population parameters are indicated by Greek letters. All the population parameters are indicated by Greek letters. All the sample parameters are indicated by English letters. In the further. Sir, okay, you are saying for the population and for the sample, you are explaining the with respect to like this. What about the median and mode? For them, there is no symbols are available. For median and mode, there is no symbol is available. Only for the mean only. Mean only the symbol is available. That is the reason I am explaining this one. Okay. So here the X bar indicates the sample mean. You are just applying the sample mean. And here you are going to take the data points and you are going to add and divide by the number of data points and you have got the mean value. Right? Next, in the mean, we are having one more type of mean also. Okay? In the mean, we are having one more type called as weighted mean. Weighted mean. What is meant by weighted mean? That is nothing but weighted average. Weighted mean is nothing but weighted average. Mean is nothing but average only, right? Weighted average. Sir, what is meant by weighted average? For example, you are having 70 and 40. Okay. Now you are going to take the average of these two. 70 plus 40 divided by 2, which is 110 divided by 2, which is equal to 55. This is okay. This is called as mean, normal mean. Okay, normal mean is also called as arithmetic mean. General mean, whatever the average we are going to consider now, that is called as arithmetic mean. Now we are going to take the weighted mean. What is meant by weighted mean? Weighted mean is nothing but you are having the different weightages. In this case, both are having the same weightage. Since both are having the same weightage, you are considering directly the average value. But if you are having the weightage for this one as different and weightage of this one is different, means I want to consider, let us assume this is the internal marks and this is the external marks. For your internal marks, the weightage is 40%. 40% is for your internal and 60% is for your external. Then you have to multiply this one with 40%. 40% is nothing but 0.4. 70 into 0.4 plus 40 into 0.6 divided by 0.4 plus 0.6. That is 28 plus 24 divided by 1, which is 52. Okay. So this is called as with respect to weighted mean. Weighted is having different weights. The different data values are having the different weight, means then you have to apply the weighted mean. If they are having the both of them are same weightage, that is nothing but 0.5 into 70 plus 0.5 into 40 divided by 0.5 into 0.5 plus 0.5, because both are having same weightage. 35 plus 20 divided by 1, which is 55, this one. Arithmetic mean means nothing but having the same weightage for all the data points. Weighted mean is but having the different weight for the different data points. Is that clear? Arithmetic mean is, what is meant by arithmetic mean? Arithmetic mean means having equal weightage for data points. For your data, having the equal weightage. For example, you are having 70 and 40, whatever example I have taken. So you are having same weightage. For both of them, you are having the same weightage. Then you are going to apply 0.7 into 0.5 into 70 plus 0.5 into 40, because both are having same weightage now, 50%, 50, which is equal to 35 plus 20 divided by 1, 55. Which is also equivalent to 70 plus 40 divided by 2. Having equal weightage. Weightage is equal. What is weighted mean means having the different weightages. Data points are having different weightages for values. Different weights for values. Is called as weighted mean. So for example, 70 and 40, this one you are considering 40% as the weightage and this one 60% weightage. Means you can't multiply 0.5, 0.5, right? Same weightage, not right? Different weightages. So 0.4 into 70, 0.6 into 24, divided by 0.4 into 0.4 plus 0.6, which is equivalent to 52. This is your weighted mean. What is the formula, sir? Formula is nothing but sigma Wi xi divided by sigma Wi. This is the formula. Sir, what data points you are having? Each data point you are going to work with respect to, this is the data point into their weight. Like this. Here in this case, I am having only 2 data points now. 2 data points and 2 weights. The weight into the data point. Okay, divide by W1 plus W2. So I is nothing but I works from 1 to n. I starts from 1 to n. N means the last number. Equal weights is nothing but arithmetic mean, general mean, average value. Generally, you are going to take 2 values are there. What is the average of these 2 values? 70 plus 40 divided by 2 only, right? That is nothing but you having the equal weightage for both of them. Okay, normal mean is nothing but having equal weightage. Is called as normal mean. Clear? Gopi, is now clear? Next one is, we are going to have the next one concept called as range. So for understanding the range, first we have to understand what is the range is going to give the entire spread of the data. Spread, how the data has been spread. What is the minimum mark and what is the maximum mark. So first you have to calculate the maximum value. In the given data, what is the maximum value? 196 is the maximum value. What is the minimum value? 139. If you remove this one maximum minus minimum is called as range. So the entire data was spreaded between the 57 points only. So for example, in this class, I have taken the exam. Okay, for the students, I have taken the exam. In the exam, the students has got the minimum value of 55 marks out of 100. And the maximum is 95. Out of 100 is this one as the maximum. Now all the students are lying between 55 to 95 only. Minimum value is 55, maximum value is 95. All the students are lying between 55 to 95 only. What is the range between them? What is the difference between the maximum percent to the minimum percent? Means 40 marks is the difference. In this 40 marks only, all the students are there. Every student are there in this 40 marks only. That is called as range. Range gives you how the data has been spread from the starting to ending. What is the minimum value and what is the maximum value? And in this only the entire data is there. Entire data is there in these values. Is that clear? Now, next one is most important one. And now please focus clearly here. Okay. Now I'm going to tell you an interesting example. So there is two cricketers are there. One is with respect to MS Dhoni, and one person is Chris Gayle. Everyone knows, right? Dhoni and Chris Gayle, right? And there are total 5 matches are there. First match, Chris Gayle has taken first match itself 100. Second match, duck out. Third match, 40. Fourth match, 60. Fifth match, 10. This is the each match score of the Chris Gayle. And if you calculate what is the total, means it is 200. What is the average? Means it is 40. Okay, keep this one aside. Now Dhoni, first match 45. Okay, 45. Second match with respect to again 42. Third match 38. Fourth match 35. Okay, and fifth match 40. What is the total runs miss? Again, it is also total is 200. The total is 200. And what is the average miss? Again 40. Two members are there. Two cricketers are there. One is MSD and one is Chris Gayle. Now out of these two, if you want to select anyone, whom you are going to select? MSD or Chris Gayle? How many are going with Dhoni? Just raise. Both offline and online. Just raise your hand. How many are going with Chris Gayle? Once again, please raise your hand. Chris Gayle. That is purely of your interest, right? Just raise, not a problem. Don't worry. Whether it is a right answer or wrong answer, just you raise your hand. Just raise. Right? Now, in this case, who are selecting Chris Gayle and who are selecting with MSD? Why? Can you tell me what is the reason why you are selecting MSD? That is, consistency is there and constant values are there. And every match, we can assume that he can play either 30 runs or 35 runs. He'll play something we are having the assumption. But whereas here, whether he'll play or not, we don't know. Sometimes he may play, sometimes he may not play. Right? That is the reason I'm taking the Chris Gayle only, which will suit perfectly. Right? So when he is going to play miss, when there is a mood miss, he'll play. Okay, when there is no mood miss, he'll duck out sometimes even. Right? Now this consistency, how you are finding the word of consistency? What is the meaning of consistency? Consistency means almost with the average value, how much it is close to the average value. how many data points are very close to the average value, that we used to call as consistency, right? Now, during the IPL auction, this is the most important word they are going to check. While selecting the player and while bidding the player, they are going to see the consistency. They are not going to see the how many centuries and how many off centuries. Their first priority is consistency. The consistency is nothing but called as variance. Consistency or variance, both are same. This is English word, this is statistical word. In statistics, we used to call it as variance. What is meant by variance means how much the data point is deviated from the mean value. How much the data point is deviated from the mean value is called as deviation. Is called as deviation. Okay. So anyone write this one first? Anyone please take this example? Can you write in your notes? Because I'm going to erase. That is the reason. Again, I have to write, but I want to bring this one to the center. I have to erase and I have to write. First I will write and I will erase. Oh, this is option is there now. And Gale 45, 42, 38, 35, 40. Total is 200. Average is 40. 100, 0, 40, 60, 10. Total is 200 and average is 40. Okay. Now, let us calculate the deviation for the Dhoni and let us calculate the deviation for the Gale. So deviation is nothing but x minus x bar. X bar is nothing but average value. Similarly, x minus x bar for Gale also. For Dhoni, first data point is 45 minus average is 40, which is equal to 5. Next one is 42 minus 40, which is equal to 2. Next one is 38 minus 40, which is equal to minus 2. Next one is 35 minus 40, which is equal to plus 5. Sorry, minus 5. Minus 5. Next one is 40 minus 40, which is equal to 0. Okay, this is the deviations of Dhoni. Now let us go with deviations of Chris Gale. 100 minus 40, 60. 0 minus 40, minus 40. 40 minus 40, 0. 60 minus 40, plus 20. 10 minus 40, minus 30. Okay, deviations are ready. Now, we can't say about the single value, right? We can't directly work on the single values. We can't focus on the single values. So what I'm going to do is, first I'm going to calculate the sum of the deviations divided by n. That is mean deviation. I'm going to calculate the mean deviation. Mean deviation is nothing but, if you add the sum, it is going to be 0. 0 by 5, which is equal to 0. Let us calculate the deviation here also, mean deviation. X minus x bar divided by n. So, sum of all the values. Again, it is 0. 0 by 5, 0. If you observe clearly, in the both the cases, deviation is getting 0. Average deviation is 0 means there is no deviation. Huh? Every data point is having some deviation, right? Here also so many deviations are there. But average is getting 0. But average is getting 0. Then how we have to work in this case? The average value is getting 0. It is saying that there is no deviation. Both of them are equal. This person average is 0. This person average is also 0. And it is saying both of them are having no deviations. There is no much deviations. It is almost saying both of them are same. So actually the answer is wrong. So now how we are going to rectify this one? So every negative value has to be converted to positive value. Sir, how to convert the positive value? So for converting the positive value, I'm going to take x minus x bar whole square. So let us assume this is the population data. This is a population data means you are going to take the mu. You have to consider the mu. X minus mu and this one also x minus mu. This is the population data. Now you are going to take the x minus mu whole square. That is 5 square 25, 2 square 4, minus 2 square 4, plus 5 minus 5 whole square, 25, 0. And now you are going to calculate x minus mu whole square divided by n, which is nothing but 25 plus 4 plus 4 plus 25 divided by 5 plus 0. That is 58 divided by 5, which is equal to 11.6. Now similarly here we are going to calculate for this one also, Crisgale also, x minus mu whole square. That is 60 square, 3600. Okay, next one is minus 40 whole square, 1600. Next 0. Next 400, 900. Average is x minus mu whole square divided by n is called as 3600 plus 1600 plus 0 plus 400 plus 900, which is 5200, 5600, 6500. 6500 divided by 5, which is 1300. Now you can see the difference. X minus mu is called as deviation. This is called as x minus mu whole square is called as square deviation. You have done the square of the deviations, right? This is called as square deviations. What is this one is called as then? It is called as mean of square deviation. For square deviations, you have applied the mean. So that is nothing but mean square deviation. Mean square deviation. Just you have applied the mean only, right? First you have taken the deviation. After that you have applied the square and you have taken the mean square deviation. So this mean square deviation is called as variance. Variance is nothing but mean square deviation. Both are same. Sir, why you are squaring? This is the question. Reason behind the squaring is if I go directly miss, the negative values and positive values are getting nullified. Why they are getting nullified? From the center value, how much you are having the right side and left side, the distance will be the same. Because you are doing from the center value, you are removing the values. You are taking from the mean, right? Obviously, center value means left side, how many values are there? That is left side means negative values, right side means positive values. Left side negative values and right side positive values will be the same. So plus 5 minus 5. Calculate the total positive values 7, total negative values is 7. So it is getting nullified. If you calculate similarly here also, positive values are 60 plus 20, which is nothing but equal to the same. Here also and here also you are going to nullify everything. It is getting nullified. There is no use. Guys, here there is a mistake. It is not 2, this is 50. Because 200, total should be 200. Total should be 200. So you have to take here 100 only. This one also 100. And this is going to be 6,200. And this is going to be around 1240. The value is going to be 1240. Concept is same. Just you have to remove the value. This should, because total should be 200. Right? Sir, why you are doing then I can show you the difference. Why I'm taking for 200 means I want to show the difference between them and I want to show the variance. So the lower the variance is the better the value. Okay, the lower the variance means he is having a good consistency. Variance is nothing but mean square deviation. First you are going to take the deviation. What is the variance formula now? Variance is equal to, first you are going to take the deviation, x minus mu, square to that. After that, mean is called as variance. Mean square deviation is called as variance. Now there is a problem with variance. What is the problem is, if you take here, this is the 100 runs. Average is 40 runs. 100 runs minus 40 runs is 60 runs. If you do the square, the runs also getting squared. Units are also getting squared. So whatever every time the units are also getting squared, all the things, units are getting squared. And finally, you are going to get variance also 1240 runs square. But I don't want run square. I want in terms of runs. So that is the reason you are going to apply the square root of this. Square root of this is x minus mu whole square divided by n square root, which is called as standard deviation. Standard deviation is nothing but square root of variance is called as standard deviation. Square root of variance is called as standard deviation. Is that clear, guys? Can I erase? Before erasing, is there any questions? Online people and offline. Yogesh, one more time, sir. Just you are going to calculate the original values and you are going to take the deviations. How much it is deviated from the mean? What is meant by simply to say variance? What is variance means? Deviation from mean is called as variance. How much it is deviated from the mean? From the mean value. From the mean value, how much each value has been deviated. So multiple values are there means we can't say for each and every value, right? For example, in this class, students marks out of 50, one student has got 20, 35, 40. 3 students I am having like this. Okay. And this is, now tell me, what is the deviation means? Deviation from the mean means, first you are going to calculate the mean value. For each value, there will be deviation, some deviation. Are you going to say for each and every student, sir, this student has been deviated from the mean this much, this student has been deviated from the this much? You are going to say for every data point? No, right? The entire data you are going to say by a single value. How you are going to say for entire data? When there are multiple values are available and you want to say by a single value means always you have to take the mean only. So whatever the deviations are there, for the deviations are also you are applying the mean. So whatever the deviations you are having, the deviations are also you are applying the mean. So first you are going to take the deviation. After the deviation, you are applying the square and mean to that. It is called as variance formula. Standard deviation is nothing but square root of variance. Square root of variance is called as standard deviation. Square root of variance, x minus mu whole square divided by n. Now, there are 2 questions. First question is, sir, why you are considering from the mean only? The reason from the mean, why you are taking the deviation from the mean only? Because I can't take from the minimum value or maximum value, or for example, 100 students are there. From which student I have to consider? Which student? Who is sitting in the first bench I have to consider, or who is sitting in the last bench I have to, from which student I have to consider? So I'm going to consider when there is a multiple data points are there, always your mindset should be mean. We are not focusing on the single value. The entire data, when we are discussing on the entire data, always we are going to work on the mean only. So here we are going to take the mean and how much the data points are distributed. Next, we are going to apply the square. Now you can ask me the next question, one more question. Sir, this is also called as mean square deviation. First you have taken the deviation, you have applied the square, after that you have applied the mean. Okay, fine. Sir, you want to convert any negative value to positive value. How to convert means you are applying the square. Why to apply the square? You can apply even the modulus also, right? You can apply the modulus also. So there is a formula for that called as first you take the same deviation, x minus mu. Okay, first let me erase this one. X minus mu. First you are considering the deviation. For the deviation, instead of going to the square, apply the modulus. Every value will be converted to positive right now. Apply the mean. Then it is called as mean absolute deviation. Then it is called as mean absolute deviation. If you consider x minus mu whole square by n means it is called as mean square deviation. One is called as mean absolute deviation and one is called as mean square deviation. Whether you have applied square means you have to write square. You have applied absolute means you have to write absolute value. Okay. Sir, Then you have explained only this one, which is also called as variance. Then what about this one, mean absolute deviation? We want variance as the maximum value or minimum value? Minimum value. So we want the minimum value. Any value you want as the minimum value, you have to take d by dx at x is equal to 0 is going to give you the minimum value. D by dx at x is equal to 0 gives you the minimum value. So if I am having y is equal to x square means, for example, any value of square is there means d by dx is nothing but 2x. And at x is equal to 0, the minimum value is going to be 0. It is fine. If I have y is equal to like mod x, sir, what is x square and what is mod x means? X square is nothing but x minus mu whole square divided by n. So square only, right? Anyways, it is square only. Square, I'm considering a simple example as square, some example of square. Similarly, modulus I'm going to take. If I apply the modulus of x, d by dx is going to be x by mod x. D by dx of modulus of x is x by modulus x. At x is equal to 0, the answer is going to be infinite. That is the reason in entire data science we will not consider the modulus. Sir, why? Why? Because we want the minimum value. The deviation, whatever the deviation is there, this deviation I want the minimum value. So when we are focusing on the minimum value, we should not go with the absolute value. This is the interview question. They are not going to ask what is the formula for variance, what is the formula for standard deviation. These are not interview questions. Why you are not able to consider the absolute values? Why you are considering only the square? In the statistics textbook, there will be square and you will follow directly the square only. You'll think, okay, the formula is like that and we have to apply. But the concept is why they have not applied the absolute, because variance should be minimum. The variance concept should be minimum. Variance or standard deviation, everything should be minimum. Minimum should be there, means modulus you can't apply. Because the minimum value is going to be the infinite value. That is the reason. Is that clear, guys? Sorry? Yes. S is each and every point. X is each and every point. Mu is nothing but mean. Is that clear? Now, next question is, okay, variance is given by sigma square. Sigma square. This is the indication of variance, which is as mu whole square divided by n is the formula. Similarly, standard deviation. Standard deviation is nothing but square root of variance. That is nothing but square root of sigma square, which is sigma, is given by sigma. Standard deviation is given by sigma, which is square root of x minus mu whole square divided by n. Okay, done. Now, variance and standard deviation. Both are population. Now for the sample, what is for sample? Sample variance. Sample variance is given by formula, notation s square. Letter by s square, which is sigma x minus x bar whole square divided by small n minus 1. Not small n only, minus 1. And similarly, standard deviation is given by square root of s is indicated by s. This is for sample and this is for population. S is nothing but square root of sigma of x minus x bar whole square divided by n minus 1. Now the question is, why you are considering n minus 1? That is the question. That is the interview question. Why you are considering n minus 1 is the interview question. For the sample variance and sample standard deviation, why you are considering n minus 1? First, if you write one more time, too fast to understand. It is faster. This is faster. Okay, Sadhana, still I will go somewhat slow. Okay, if you feel this is fast means I will go slow. But actually this is not fast. So now, have you taken the formulas? Done? Now, why we are going to consider n minus 1 for sample? Why n minus 1 for sample? This is the interview question. Answer is Bessel correction. Bessel correction. Now, again question is, what is Bessel correction? Okay, Bessel correction. Okay, what is Bessel correction? Who has corrected this one? Earlier, they used to work on directly divide by n only. They used to take n only directly. He has came and he has told that n minus 1 you have to apply. You can't apply the n directly. And what he has, why he has told like that means, the thing is that, for example, let us go with an example. X plus y plus z is equal to 30. Tell me what is x and what is y and what is z? 20, 10, 0. 10, 10, 10 I can consider, 20, 10, 0 I can consider, 0, 5, 25 I can consider. Multiple values are there, right? Multiple options are there. Infinite number of options are there. For selecting this one, you are having infinite number of options. Okay, let me fix one. Any one, let me fix. Let us fix this one as 10. 10 plus y plus z is equal to 30. Now tell me what are the options for y and z? Again, infinite number of options, right? Even you can add plus 100 minus 80. Z can be minus also, right? It is mandatory that z should be positive value. No, right? Anything can be there. Again, infinite number of options. Now let us fix one more value, 15. Z is fixed. There is no other option. For you, no option is left. 1 is not having the option. There is no option. You have to select only. Whereas now here in this case, you can select your y, you can select the z. Number of options you are having, right? For this, is there no option for this? In this case, there is no option, right? So always one will be left out with no option. Okay. So some students will not be satisfied with one example, right? For them, one more example. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Total 7 days. I'm having 7 shirts and I don't want to repeat. 7 shirts are there and I don't want to repeat. On Sunday, how many options I'm having? 7 choices you are having. On Monday, 6 choice. 5 choice. 4 choice. Out of 4, any one you can select. On Thursday, out of 3, any one you can select. Out of 2, any one you can select. Here, that is not called as choice. That is mandatory. That is called as mandate. That is not, everything is called as choice, whereas one will be left out with no choice. There is no option for that. Always one will be left out every time. Bessel has explained this one. And the population data, from the population to sample when you are collecting, one will be not having the option. You have to select only. That is the reason we are going with n minus 1. Is that clear? That is Bessel correction. That is the TCS exam question. TCS exam question, that is. In the TCS exam, total 25 questions you are going to get from the descriptive statistics. Whatever we are going to discuss today, yesterday, today and tomorrow, from these 25 questions will be there. Total. Okay. So this, for variance, you are going to take n-1 for the sample and automatically for the standard deviation. Considering n-1 for the sample is clear, right? Yeah, I'm going to explain. Don't worry. I'm going to explain with one by one examples. I have bought number of examples. So here I'm having with respect to 5 values. Now I'm going to work on the sample. Okay. So this, I'm going to take the, first I'm going to calculate the average value. So X bar, that is sigma of Xi divided by N, and 10 plus 12 plus 16 plus 19 by 20. And I'm going to calculate 15.4. Now 10 minus 16 minus 15.4, 19 minus 15.4, and 20 minus 15.4. This is all called as deviation. Every point is deviated from the mean. How much every point is deviated from the mean, each and every point. And you are going to apply the squares of the deviations. After applying the squares of deviation, just you are going to calculate the sum divided by n-1. And you are going to get, this is, if you want the standard deviation, is square root of that value, which is equal. Is that clear, guys? First, you are going to calculate the deviations and after that squaring. Once the squaring is done, now you have to calculate the sum of the deviations. Miss this one, this one, this one, this one, this one. You have to do the total. That is 29.16 plus 11.56 plus 0.36 plus 12.96 plus 21.16. Total is 75.2. That is the total. That is numerator. Denominator is n-1. Total 5 data points are there. 5 minus 1, 4. 4. Square root 18.8. Square root of 18.8 is 4.366. Clear? Once again, sir, Bessel correction. Bessel correction is nothing but one will be left out with no choice. Is called as Bessel correction. One data point will be selected with no choice. Right? Next one, I told you the sample mean is indicated by X bar, population mean is indicated by mu. Similarly, sample standard deviation is indicated by small s, population standard deviation is indicated by sigma. We are going to work on the sample standard deviation only, not variance, because variance is having the unit square, right? Every unit is getting squared off. So the total answer also we are going to get the square of the units. So we are going to work only the standard deviation. That is the name they have kept the word as standard. This is the standard value. So that is the standard deviation. So here for the standard deviation and mean, we are going to majorly we focus on these two parts. Right? Mean and standard deviation. The sample values, whatever the sample values you have collected, they are called as sample statistic. Whereas for population, they are called as population parameters. Okay. So what is this statistic means? Sample statistic mean. They used to call it as sample statistic mean. The name for this is called as sample statistic mean. For population, they are going to use the word as population mean parameter. The word of parameter they are going to use. Okay. Statistic means sample data. Parameter means population data. Now, what this standard deviation tells us? Okay, you are identifying standard deviation. Now, what is the use of standard deviation? Data has been deviated from the mean. It is going to say how much the values are close to the mean, how much they are deviated or how much they are close to the mean. So if the deviation is small, means every data point is very close to the mean. If the deviation is high, means every data point will be somewhat far away. The larger the deviation, the larger the data points. If the deviation is small, means they are very close to each other. Is the clear? If you measure the spread, spread of the data, okay, then you have to see the standard deviation, not the mean. Variance and standard deviation both are same, right? Square root only, right? So if the higher data set means the deviations are more. If the standard deviation is small, means they are close to each other. Next concept called as percentile. Okay. Is that okay if I continue or confused? If you want to stop, means I'll stop. If you okay, means I'll continue. Continue. Stop. One person stop. Please raise your hand. How many wants to stop? Okay. The students are loaded very heavily. So let us go in, let us stop. Before stopping, let us complete a small topic. Just a 2 minutes topic. Okay. So we are having the distribution of the data, right? This is called as distribution of the data. Now, for the distribution of the data, let us wait. Just give me a minute. Let us go with a small part. So distribution of the data. Distribution of the data, if the data is symmetrical means left side and right side, both the diagram, the histogram will be same. If from the mean, if you see from the center, if you draw a line at the center, the left side and right side, if the both are symmetrical, then it is called as symmetrical data. Okay. The symmetrical data is also called as symmetrical distribution, is also called as normal distribution. What is meant by distribution? Distribution is nothing but distribution of the data. These bars you have distribution of the data, right? Now the data has been distributed normally or symmetrical. This is called as symmetrical distribution. If the data is unsymmetrical, unsymmetrical means they are not equal. From the center, they are not equal. Then it is called as unsymmetrical data or skewed data. Unsymmetrical data. Skewed means unsymmetrical, means which are non-symmetrical. Unsymmetrical or non-symmetrical. Okay. Which is non-symmetrical. Which are non-symmetrical or unsymmetrical. It is called as skewed data. So skewness means it is going to tell about whether the data is normal or not, means whether the data is symmetrical or not. So this is called as left skewed. Left skewed means the values on the left side, the values will be high. The right side values will be very high. More number of data points will be on the right side from the mean. Okay. Let us take here, I'm having 2 values, 3 values, 4 values, 6 values, 8 values, 10, 9. And this one I'm going to take as, let us change this to 5 and 4. Okay. Means from the, after the mean, total you are having 8, 10, 9. The very less number of values are there. If less number of values are there towards the left side, then it is called as left skewed distribution. Skewed means less number of values. Okay, left side less number of values are there. Then it is called as left skewed distribution. So your mean value will be always at the center point. But whereas median will be with respect to the center location, right? For example, here I am going to take one more example. See, two number of data points. 3, 8, 10, 9, and this is 4. Total how many number of data points? 2 plus 3, 5, 10, 16, 24, 34, 43, and 47. Total 47 data points are there. Now 47 data points, what is the central location value? 47 plus 1 by 2, which is 24. 5, 10, 16, 16 plus 8, 24. Means this is the location will be there. Means the median value will be here. Median value will be after the mean only. So the median will be more than the mean. What are the mean value you are having? The mean is less than the median. The mean is less than the median is called as left skewed distribution. This is the TCS question. In the TCS entrance examination, we are having the multiple choice questions, right? There it is going to show you if the mean is less than median, what type of distribution? Symmetrical, left skewed or right skewed? That is the question. If the mean is less than the median, it is called as left skewed distribution. The median value will be, okay. And see, let us take here the example also I have taken. So 1, 2, 3, 4. 4 students are there with respect to this one. 2 students, 3 students, 4 students, 5, 7, 10. Now in this case, what is the mean value? Mean is always at the center. It is not going to change. Center value. Center value means center value only. Now whereas median is dependent on the number of data points. 1 plus 2, 3, 6, 10, 15, 22, 32, 46. 46 plus 18, which is 64 plus 73 data points are there. In this case, 73 plus 1 divided by 2, which is 74 by 2, which is equal to 37. So 37 means the data point will be here in this case. Obviously, the median value will be here somewhere. So the mean value is 12, median value is somewhat this one. Then it is called as left skewed distribution. Is that clear? Next one is right skewed. Less number of values on the right side, it is called as right skewed distribution. In this case, the median is going to be less than the mean. Okay. If mean and median both are same, then it is called as symmetrical distribution. For symmetrical distribution, both of them are going to be the same. Mean is equal to median. Is that clear? You can write like this. If mean is equal to median, it is called as distribution, symmetrical or normal distribution. It is called as symmetrical distribution or normal distribution. If mean value is less than median, then it is called as left skewed distribution. If the mean value is greater than median, then it is called as right skewed distribution. The values will be low and right side the values will be high. Left side the values will be low. Then it is called as left skewed. Right skewed means right side values should be low. This side the values should be very low and left side the values will be very high. Right? Which side the values are very low, that side that is called as distribution. Left skewed or right skewed. Clear guys? That is called as skewness. That is the end of the session for today. And we'll see balance part tomorrow. Right? In today's class, we have discussed about the mean, that is population mean and sample mean. Median. Median is the center location, whereas mean is center value. One is center location, one is value. Mean is called as center value. Median is called as center location. Mode is most repeated value. Okay, that is mode. After that, we have seen the minimum value. Minimum means what is the in the given data, whatever the minimum value is called as minimum value. In the maximum value is there, that is called as maximum value. Range is nothing but maximum minus minimum. After that, we have seen the variance. Variance is nothing but mean square deviation. So we are going to calculate the deviations and applying the square and applying the mean for that. So which is equal to x minus mu whole square. And after that, you are going to apply the mean. That is sigma of x minus mu whole square divided by n. That is population mean. And similarly, standard deviation is nothing but square root of variance is called as standard deviation. Right? And finally, next one is with respect to Bessel correction. Bessel correction means every time one will be left out. That is not called as choice. That is mandatory. Every time one will be left out with no choice. So at that time, we have to consider that one. So for example, if you are showing 3 fingers and asking to catch any one finger miss, that is called